So I'm from, well, nowadays Siemens Digital Industry Software. Before that was called, well, our group has been at Mentor Graphics, which has been acquired by Siemens. So you may be familiar with that name. So yeah, GCC, the GNU compiler collection, free software, open source software compiler. So, and I may place this call here. So Jeff earlier asked for people to help with the LLVM effort. So likewise, you may join in with the GCC, OpenACC, OpenMP, whatever efforts like. Sorry. So we've got always several GCC branches. I will keep that short. So the current stable release is GCC 11 that has been released in spring this year, featuring OpenACC 2.6 support with code offloading to AMD GPUs and NVIDIA GPUs. On top of that, we maintain the OG11 development branch. O stands for OMP, and that does not stand for OpenMP here, but for offloading and multiprocessing. So that's a shared public development branch based on GCC 11 with additional work committed on that branch, work that is current development or what we inherited from earlier development branches, and that is meant to go into the mainline GCC branch eventually. And with that, this development branch provides a kind of a feature preview, what will end up in the stable GCC releases eventually. GCC 12 is the current major development release, not release, but branch, which is to be released in spring next year. As of yesterday, it's in a stabilization phase to make it fit for release. So only features may go in now that have already been submitted earlier in the year. That's the annual development schedule that GCC has. What we at Siemens have done last year, what our focus was very much on the OpenACC kernel support, which was basically non-existing in GCC. So I call it here a compiler magic, and I will skip over that in the interest of time. There was a presentation of my colleague Frederick Harvard at the Linux Plumbers Conference GNU Tools track earlier in September. You may look into that if you're interested in the technical details. That OpenACC kernel stuff has been developed on a private development branch, which we are now currently integrating into the public OG11 branch. And from there, it will later go into GCC mainline. Unfortunately, not for GCC 12, but for a later release then. Further, what we have done last year primarily is revision and upstreaming of existing development work from the OG11 branch and its predecessors. Okay, that's that. All right, so this revision and upstreaming we have integrated into GCC mainline in time for GCC 12 preparational work for OpenACC kernel support. To decompose kernels regions into several independent compute regions, which will then be sequenced and handled by the compiler individually. That's directly coming from the semantics of the kernels construct. We have added OpenACC worker parallelism for AMD GPUs. So for NVIDIA that already exists, but for AMD there were some technicalities that some things needed to be done differently in GCC. Right. A big thing was the debugging support. So interactive debugging using GDB or a ROC GDB variant that AMD maintains. And with that, I guess you could use any kind of front end you may use for GDB. And you can actually step through the host and device code boundary and single step the GPU code. of course, you cannot easily step individual vector instructions and things like that, because that's difficult, but at least at the worker level and the gang level, that works. And there again, it has been a demo of my colleague Andrew Stubbs at the Linux Plumbers conference in September, which you may also want to check out if you're interested into that. The same should in theory be possible for NVIDIA GPUs using the CUDA GDB. But I don't have any information if it actually just works or if there is any work to be done. So GCC, for example, needs to provide the debug information or feed that down to the device compiler so that the device runtime libraries and things can find the appropriate symbols and all these debug things. Yeah, but if it works for AMD, it can be made work for others, definitely. Right, and then, well, the usual bug fixing and this kind of things, like making GCC adhere to the OpenACC specification. For example, just a few here: data privatization at the gang level, where we have to use GCN LDS or PTX shared memory. We have done quite a number of Fortran front end and GCC middle end changes to support data types that appear in Fortran. Done stuff regarding asynchronous correctness. Every once in a while, we have to fix up some things when incompatible changes or deprecations are done in the HSA, LLVM, or CUDA PTX worlds. Well, yeah, and the usual stuff. We have done some code generation optimizations for all these targets and worked a bit, at least on more user-facing diagnostics. For example, here this at diagnosing suboptimal choices of OpenACC parallelism. Next steps are more revision and upstreaming of the existing work into GCC mainline. We have been hired to implement OpenACC 2.7 features. That has not yet been scheduled, but it should happen next year, as far as I'm aware. Maybe any one of you would like to hire us for the even more recent OpenACC standards. Well, and always we do what we call directed services work as prioritized by our customers, like bug fixing, performance enhancement, OpenACC features, interoperability with other implementations or platforms, generally new offload devices. So there has been a question about Intel GPUs. I would love to work on that, supporting GCC OpenACC on an Intel GPU would be a fun thing. As far as I can see, currently Intel do not have any interest really in making it work for OpenMP in GCC, unfortunately. So I asked the question and tried to extract a useful answer from them, but didn't get any. So no idea what's going to happen there. Right, and we intend to continue working, of course, with the OpenACC technical committee. That's primarily me and my colleague Tobias Bonus. Yeah, and that's all I have here.
Thank you, Thomas. Okay, so let's see. Stefan asked any plans to supporting Intel GPUs. You answered that. Ron asked, can you please post the 2 links for AMD debugging in the chat or in Discord?
I will do that.
Thank you so much. Guido asks if GCC support for AMD GCN also support the MI200 series.
Okay, I'm not too familiar with the AMD code names. The latest that we support is what's internally called GFX 908. So I don't know if that matches. But typically the, the changes required are not too invasive. It's just that the GCC GCN backend has to know the exact target architecture because that gets encoded in the assembly files that we generate.
Okay. Georgios asks, he makes a comment and then a question. Although performance of OG11 is improved, it is still behind in the performance compared to other compilers. What is the performance vision? I had heard that you are in the functionality level for now.
Yeah, well, of course, we are still catching up on everything, on the functionality and obviously also on the performance. We're a rather small team working on that. Did definitely make good progress in the last years, but yes, there is still a lot of work to be done. It's hard to answer that question. So if people are interested in improving that, come talk to us. If you have a specific code that you need optimized, yeah.
Okay, and then so Dave, we're not going to go backwards right now for time, but we're recording it, and I think the slides will be available afterwards, so that you can work on your session summary. Sunita comments that MI200 is GFX90A, so I guess not at the moment. And then the question, where is OpenACC support for ARM processors at? Maybe I direct that to Jeff Larkin. Jeff, are you still there?
Yeah, I mean, for ARM processor, the NVIDIA HPC compilers do work on ARM processors. We officially support server class ARM processors. You may be able to unofficially get it to run on other ARM processors, but we do definitely support it with the HPC SDK, and that includes both running with multi-core, across the cores, or on an attached GPU.
Any other vendor want to comment on ARM?
So in GCC, it should be able to make it work easily, given that all the code basically is generic and just needs very minor changes per CPU architecture. We have not worked on that yet, but if somebody is interested, again, come talk to us.
So are you talking about generating threading on the ARM from OpenACC?
Is that question for me or for the person who asked?
I think for the question asker, why I'm not sure who it is. Wahid?
Okay. So this is John Levesque.
Yeah.
Okay. So we do have a mode that either OpenMP offload or OpenACC can generate OpenMP on the host. But we also, so therefore we generate code for ARM from OpenACC and OpenMP offload. But we also generate code for ARM with attached processors.
Okay. Question from Dave. Would you still recommend using the GCC vector extensions? I think this is directed towards Thomas.
I have not encountered these working on the OpenACC or also OpenMP target support. Which do you mean exactly? Like hardware or processor specific intrinsics?
Dave, would you like to clarify?
So they're not intrinsics. There's some feature in GCC, which I think Intel also adopted, where the cool thing about it is it allows you to do both the AVX 512 and the earlier version of AVX with just one code base, and the compiler kind of uses multiple of the 256-bit vectors in place of one 512-bit vector. So it's an extension of the C and C++ programming language that's not part of standard C, but it's something that GCC added in, and then Intel, and I think someone else may have copied it as well.
I'm not familiar with that.
Okay.
But it looks as if that more applies to the CPU side as opposed to OpenACC GPU offloading.
Oh, I think you could use it on the GPU. Not that I've tried it myself, but yeah.
Okay, on this topic, Duncan comments, if the person asking means the scalable vector extensions, SVE, if so, ARM has a compiler with SVE support.
Yeah, and GCC will also support that, I think, in the upcoming GCC 12 release, if not in the current one. But again, that's for host CPU side.
And then there's a,
I'm
gonna move on. We're running out of time. Sorry about that. There's a jump ball question. Any support for Qualcomm Snapdragon?
I don't know. So nothing existing at present could be done, I guess.
I'm not aware of any that support it. I would guess GCC may work, but it's probably untested.